The only controller you can buy that this robot will talk to is this one. It costs more than the robot does. So I made this one. Last episode's board was a brain wired to motors. This is the same brain wired to hands. Now, Bluetooth is a vague term. Turns out there is low energy and regular. This is the only low energy Bluetooth controller I can find. The free option is that web page from episode 6. But a touchscreen has no edges. A slider you can't feel is a slider you have to watch. So you drive looking at your thumb instead of at the robot. Both of these options aren't great because they're on someone else's hardware. This is our hardware. There are 2 joysticks on this board, and I'll be honest, these joysticks were the hardest part of this whole build. Let me explain why, and at the same time show you what to do if you run into this situation with maybe another obscure part. This part has 14 holes, and nobody publishes where they go. No library part, no datasheet, just a scan of a drawing. But you can get a real measurement out of a picture. If the one scale factor that makes the 3 stated dimensions come out right, then check whether that same factor also predicts 5 other numbers the drawing happens to mention. Mine did. And you can prove a footprint before it exists in copper. Put it at actual size, check the ruler on the sheet really measures 50 millimeters, and push the real part through. Paper isn't copper. The only way to close that gap is to spend the money, which is where PCB comes in. They're today's sponsor, and they made this board and last episode's. You upload a Gerber zip, and PCB reads the board straight off it. Size, layers, holes, and quotes you. I did that twice, 1 zip each. Both land in the same cart on 1 lot of shipping. 5 of each because 5 is PCB minimum. And that's the part worth knowing. The expensive bit of a prototype run isn't the board, it's the shipping. So a second design riding along is very nearly free. PCB 3D print as well as fabricate. I ran this shell off of my own 3D printer. But if you haven't gotten one, it rides in the same cart as the boards. PCB had this board on my desk in 4 days. That's what makes a board you're unsure about worth sending. Being wrong costs a few days and a few dollars. The PCB link is in the description. Register through it and you get $5 off your first order, and it helps me out. Straight in. 14 terminals, no persuasion. The paper was right. So, what goes into this board? The brain in here is the identical part that's in the robot. Cheapest module I can buy, doing 2 jobs with nothing in common. Front and back are split for a human reason, not an electrical one. Everything a thumb touches is on the top. Everything else is underneath. The module's 2 rows of pins leave an 11.5 millimeter gap down the middle of the board. A joystick's hole pattern is 11. So the left stick doesn't sit beside the brain, it sits on top of it. And the 2 sticks wasn't a decision. 5 pins on this chip can read a knob. A stick needs 2. The 5th you can't trust at power up. The brain gets sockets, not solder. The most expensive part of the build pulls straight back out and gets spent on something else. no pairing, and no network. ESP-NOW is the same radio hardware talking directly underneath everything Wi-Fi normally insists on. Everything a controller has to say about driving fits in 12 bytes. It says it 50 times a second. And it doesn't know the robot exists. No address, never asked for one. It broadcasts into an empty room, and anything listening drives. Nothing to agree on means nothing to break. A second robot listening to the same controller will take the same commands this one is getting and act on them too. The robot already knows all three ways of being driven. The firmware supports all three. You pick one when you build because there's one radio. And it does one thing at a time. Just to say it another way, all I had to do was change one flag on the firmware from last episode to switch to the ESP-NOW protocol. The electronics hang off the lid, not the tray. The whole stack lifts out in one piece, and the tray is just a shell. A flat box wide enough for 2 sticks would have been a brick. Nothing to wrap a finger around. So each end grows a lobe that comes out to meet your hand. The firmware has no idea where to center. It reads center the moment you switch it on. And which axis reads backwards is the guts of the joystick you happen to buy, not the board. There are 4 flags in the firmware. Push a stick. If it's backwards, flip the flag. The Gerbers, the 3D printed parts, the firmware, and the one-to-one joystick template are free at minirobo.io. Links in the description. One stick, push it where you want to go, and the robot works out what each wheel does. A stick you can feel gives back what the touchscreen took. Slow is a real option, and I never look down. The 4 moods are still from episode 6, and you ask for them with these 4 buttons in the middle. No network is involved in any of this. I can walk out of the building. You'll note this robot isn't making use of the left stick. That just means we have room to grow. Everything from today is free on the site, and thanks to PCB who made both boards. See you next time. Let's build something.